Hey, YouTubers, Tazman here, bringing you another episode of Taz Teaches Java. And in this episode, I've kind of contemplated about this episode quite a bit because this is something, an interface is what we're going to learn about. And interfaces really, they're hard to understand their purpose until you really need it. And for small little projects like this, generally you won't, for most of the things we'll ever do, do on this, uh, we might not even need interfaces. But I think it's kind of a good thing to kind of just at least, wet your whistle, get you an idea of what it is, so you know it exists. But really, if you don't understand this, or if you don't understand why on earth would I ever use that, or that doesn't make much sense, or anything like that, interfaces right now are the ones I would say take with a grain of salt. And it's okay if you don't fully understand it, because like I said, even for me, for something just as simple as I can make a quick video about, I'm like, well, why would I really even care? I mean, I could do this just as easy, but it's usually in larger scale projects you'll see it. So let's just talk a little bit about interfaces real quick. And just so you know, a lot of this code I've already written because I recorded this video once, and for some reason the footage had corruption about 3/4 of the way through. So I've deleted the pertinent stuff for interfaces, which is why here we're seeing an error. Here we're seeing some, well, we'll see those the whole time anyway. But all the files are created. And if you want to create an interface, all I did right here is created an interface package. And if you want to create an interface in Eclipse, you simply just come down here to interface, give it a name. It kind of follows the same rules as your classes, so uppercase. And there you go. So as you can see, now interface name. So if we look at this in objects, so a class is a noun, right? A class like a vehicle, a class like a person, a class like a student, a teacher, they're all nouns, person, place, or thing. Then inside your class you have methods, and those were the verbs. We've talked about those too. We have eat, we have run, we have jump, we have swim, we have dodge, we have fire, we have, all kinds of, our methods are verbs. So an interface could be described, and generally when you name an interface, it might have an adjective type of thing. So you can usually turn a verb into an adjective by adding able to the end, able, right? So you could say runnable, which means, is it runnable or whatever. Or also, as you can see here, we're using can. So can fly, can swim. For, fly obviously is the verb, and swim. So you can kind of use those two. It didn't make sense for me to say flyable. Well, I guess I could have done that. But I just did can fly, can swim for it. So an interface is in Java. My wife's phone's in here. An interface in Java is similar to a class, but the body of an interface can include only abstract methods and final fields. Now, final fields are your variables. They have to be final, which means they're constants, and they need to be static. Now, we've kind of learned, I think we've talked about it before, but a static thing is something that can't be instantiated or can't be created. So, for example, main in our programming, public static void main. This is static because we don't actually create a instance of tester, right? So this is basically something that we can access, or here we can access main without having to have an object to attach it to. So for example, if fly here, and this is an error because it doesn't exist yet, but if fly here were static, we wouldn't necessarily have to have bird. We won't have to have an object to attach to it. So that's what your static things are. And in an interface, like here we have can fly, you can create something. We could say like, well, actually, even if you don't name it, like if I just say int, or actually let's do double and say final. I don't even think you have to say, if you even don't, let's just try this how we're doing it. Let's just say pi for, oh, and then let's say, you'll see actually it already is telling us here that this cannot, pi hasn't been initialized. So if we initialize that to say 3.14, right? Now it seems happy. Now if we were to try and access this, and of course we can't access it unless we actually implement our things. So if we just, for example, came in here to, let's just say Birdman for a minute, and we said implements. So this is how you access or tell Java that you're connecting into an interface. Now, I kind of getting ahead of myself. Like I said, this is pretty complex stuff. So when here we have a Birdman that extends human, and this is because all Birdmen are human, all mermen are human, so both of those extend human. However, not all human are Birdmen or mermen, so that's why that's not. So that's where we get, this is the superclass, these are the subclasses. Both these extend that, which means Birdman has access to age, weight, is tired, is hungry, and as does merman. However, merman does not have access to flight speed and altitude, nor does Birdman have access to swim speed and depth. So, this is really kind of hard to keep my train of thought here. So here we're doing double pi 3.14. So if we do implements and we say can, did I do it right that time? Implements. All right. Can fly, because that's the one we're doing it in, right? So I have access to that. If I said pi, or maybe let's say, could we do it this way? Could we say double altitude? Let's just see if this works. Pi. So as you can see, it's plenty happy with pi being there. However, even though I didn't necessarily or explicitly set this to be a constant, it still is treated like a constant just because it's in there. So if I tried saying, let's see, pi equals 3.15, this is not going to like it because, hopefully it's not going to like it. Did I do a colon there? Semicolon. Actually, let's just get rid of this guy for a minute. Or is that what it's talking about? Expected double altitude. Why is that? Expected comma comma. Altitude is not used, which we're fine with. So is it this guy causing that issue? It is. So yeah, it's given us a weird error that it doesn't necessarily know how to handle it. And part of that is because this, even though you don't necessarily define it that way, is a final. Fi. Actually, I guess we do final here, right? We say final, and it's static. Now, static means we can't, it means that this variable is accessed the same by every single, like if we have objects over here, they're accessing this directly. So if I can't really change it because it's final, but if, for example, this wasn't in an interface or anything and it was static, that would mean that, like, if I had a counter how many guys I had or something like that, how many humans, that's static. It means it's not part of an actual object. It's its own little chunk of memory, and all the objects that reference it share it. So as that number would go up, all of them would have access to them individually. Hopefully that makes sense. If not, like I said, take it with a grain of salt. We're not really going to go too much into the variables. I just kind of want to tap on that. So a class implements an interface by providing code for each method declared by the interface. So I've mentioned before, an interface is kind of like a contract with the class. If I have something in here and we have can't fly, well, if I create a method and it's not the standard type of method, once again, I'm kind of getting ahead of myself. Maybe I should keep reading my notes real quick. So it says most interfaces are named with adjectives rather than nouns. We kind of covered that. They describe some additional capability or quality of the classes that implement the interface. All the methods in an interface are assumed to be public and abstract. So I don't necessarily have to put the public on there. It's kind of implied, but I can. I could say public, public, and say void because we don't want it to return anything. And then we could say fly, right? And we could say it doesn't need anything to be passed into it. And we can go ahead and do that. Now, the difference between this is more of the way we do our method definition. We're just telling it information. We're passing to this guy, and now you'll see Birdman is not going to be happy with us, and it has a red thing or a red line. And the reason is it says it must implement the inherited abstract method canFly.fly, right? So what it's saying here is it says, hey, I have a contract with canFly, and canFly just so happens to have this fly method. I do not have that method located in me. I need to have it. And so that's what it's saying right there. So if we have another in here, let's say with fly we also have jump, because that's kind of like a really short flight, right? Short fly up and back down. So we don't need the public. We could just say void and jump. And here we could actually say, okay, well, let's say also let's say with fly, let's say int speed, comma int height. How high do you want to fly and how fast, right? Where jump is kind of constant. You just jump and you maybe go a foot or two, where flight you might go more. So if I want, I can actually come in here and I can hover over this and it'll say add the unimplemented methods, right? So if we do that, you can see it automatically adds the notation for override to let us know that this is overriding something. And as you can see, it automatically created our two methods. So now in here, where this is the Birdman, he can fly, we're just going to say, just to keep it short and simple, S out, let's just say FLYING, so something like flying. However, let's say a merman, he can't. Let's do this, IMPLEMENTS, implements, and do a C. So can't fly. So he's going to want to implement this too, right? However, a merman can't fly. So what we would want to do maybe here is, and there's no reason to pass in a speed or a height because he can't fly. He can dive. So here we might say something like S out. Let's do this and say I can't fly. Something like that real quick. Or, you know, maybe I need an airplane or something. I don't know. So here, now we're implementing it and they're happy because we're meeting the requirements. I think we still need to, we need the dive method still. Actually, let's just comment these out really quick just to show you. So now if I run these, Both of these know that they have to have that fly method, and so they have the fly method. As far as running this goes, it could care less that these things even exist, because all it's caring is I come in here and I say fly. It's being overridden. It's overriding what's in there because, well, there's nothing there. And then one of the things that interfaces are really used for is to really work with overriding polymorphism and stuff. So just because this is kind of what I was talking about a little earlier, and I got off track when we were talking about the human and how all humans can be a birdman or a merman, but not all birdmen are human. That's called your inheritance, right? But I can't actually inherit multiple things. I couldn't say a human and a reporter or something. So I can't extend human and reporter. You can only extend one thing. And that's kind of where these come in, where you'll be able to have these contracts or access methods or permissions of methods or ideas of the methods outside. And like I said, take it with a grain of salt. Really kind of hard to explain. So if we run this now, if we hit save, we should get that all clean. We're good. These guys right here, just because we're not using those. And we really don't need to. So if we hit run, you can see Birdman here, since we called him first, he's flying. Fish or bird here, the Birdman, he's flying. Fish here, he can't fly. So this is fine and dandy. However, let's say we have other things that maybe can't fly and can't, like if we said with this, we could say everything can swim, right? So we could say don't return anything, whoops, void. And we could say swim, swim, and it doesn't have anything. Now this is basically abstract. When it's an anonymous method, or abstract method means that it doesn't actually contain anything, which is why we put the little semicolon at the end of it. And we say void dive, and then once again, how fast are we going to dive? Maybe we do int sped sp int and depth int depth, right? And there we go. So now these guys, as soon as I tell it to also implement this guy, did I mess something up here? Is that a colon? I think it's a colon. There we go. So a semicolon. So as soon as I implement the can swim, right? So if we say, and that's where these things come in, is they kind of allow you to, you can implement as many interfaces as you want. However, you can only extend one other class. So we could say can, and say swim. And now once again, this is not going to be happy with us because, well, Birdman doesn't have any of those. So we could actually come in here, whoops, mouse over it, and say add unimplemented ones. And now we have a swim and a dive. If we say birds can't dive, they can swim. They can, you know, like a duck, swim on top of the water. But here we could say s out. I cannot dive, right? Then, of course, Merman's not going to be happy with this either. And say can dive, or can swim, I mean. So he's not going to be happy because we're not implementing those. I want to keep right-clicking it, so we add those. And now everything's happy again, and we can even turn back on these two guys. And actually, Merman's not going to say anything when we tell him to dive right now because he's not set to. So we could say s out and say diving. Diving. So now if we look at this, we will see that when we run it, we got flying, but he cannot dive, and diving, but I cannot fly. So yeah, this, like I said, it doesn't really make sense because I'm actually writing all the methods. This is kind of redundant. Now, one place I can understand that this might be handy is, let's say we have like Mole Man, or, you know, many, many different things that maybe they can't fly and maybe they can't dive, but they can do their own thing. Well, that means I have to write I can't fly, I can't dive, and everything in each of these things. And so this is one place where you might be able to do a little more with your interface. So for example, we have our public void here. If we say default, we use the keyword default, D-F-A-U-L-T. We do that, and then we have to keep that semicolon, but we want to add our body like that. What this is going to do is this is going to make us say, okay, this is absolute a contract. You have to have this in your class. You just have to, period. If you don't, you're in violation of the contract. However, if this is default, this says, okay, this you should have in your class for the can fly to be valid. However, if you don't, I have a default one that you can use. And this is where we could say for can fly, we can actually go to merman and grab his I can't fly and do Control X. And we can stick that right there. And now we can actually delete this fly method from here without having any issues, because we're still not in violation of our contract here. We have said, okay, we do have a jump. We don't have to have this. Now, another thing is, if I have this set up and, for example, I come into, which one is that? This is can fly, right? If I were to delete the jump method too, once again, it'll be angry with us because it doesn't meet the contract minimum, right? So we mouse over this and it'll say, no, you have to have something. Now you'll notice when I do this, it only added the jump. It did not add the fly because it has the default. That's not part of the contract that you have to have that in there anymore. So this is something that was new with Java 8, where you could actually have kind of a default setting, which means now if I have a mole man or whatever other kind of man you can think of that can't fly, I don't have to add the fly method into them, and they'll automatically say I can't fly. And we can do the same thing with the bird man. We can go grab I cannot dive from here and go into swim, and we can change this guy by saying default. And then we add our body, and then we just put in our I can't dive, and it's happy. Now, one other thing to note is this is not a thing that can be instantiated. You can't create an object of can swim. So that means I can't use variables from Birdman because this is the template, right? This is a blueprint. So I can't access flight speed or anything like that. So I can't access variables, instance variables, from within here. So I can't have things that say, oh, well, if flight speed, I can't use that for a default thing. This basically can only be really very basic things. You can do outputs like this. You might be able to access your variables, your constants and stuff like that. But this is more of a thing just a convenience to say, hey, now you don't have to have in Birdman a dive method if he can't dive. There's no reason to do that. It's just a waste of space. And you have to actually have that in every single thing that uses the can swim interface. So now you'll see everything is, we don't have any little things other than these little yellows. That's because we're just not using them. But everything's happy. So we're meeting the contracts or what we've guaranteed we're going to have. And we have our default. Now, the thing to note here is because this is default, if I were to remove the swim and dive, actually I'm going to copy this guy real quick, just so we can do it quick. If I were to remove the swim and dive, the interface has no clue that Merman actually can swim it, and it wants to have that other abstract method, or the method that we defined in there. So if we hit the thing here, do this, mouse over, hit implement, you'll see it only did the swim method, the one that we have to have. It did not do the dive method. So you will have to add that manually for it to work right. Other words, we'll get merman saying he can't dive either, which, what kind of fish is he? So now if we run this, we should see this exact same thing, but we don't have to worry so much about that. So in fact, we're at 25 minutes. Maybe we could make a quick mole man. That's one thing I didn't do before. So if we go here, you see flying, I cannot dive, so he can fly, but he cannot dive. Diving, but he cannot fly. If we were to just quickly, let's just try this. We'll just make a really basic mole man. So we want new, we want a class, and we'll call this mole man, right? So this guy, he can dig, but we're not going to do a can dig thing. We're just going to know that that's there. So mole man, he also is a human, so EXTEND extends human. And we're going to get an error here because it's going to say we're not meeting the human expects us to pass it something. So if we do this and we say, okay, implement that constructor for us, you'll see that it wants us to implement it. We actually don't need these because through the chaining, we don't need those. So here we go. We can get rid of these two also. All we have to actually pass it is that. So there's our constructor. The next thing we would say here is we would say implements implements, and we want can, right? Can fly, comma, can swim, right? Swim. And now, of course, we're in violation of our contract, so we can do this. Oops, I keep right-clicking. We can do this. We can add those unimplemented. You'll see it only added the two because those are the contracts. So now if we made a mole man in here, all right, came in here and we said, oh, actually, let's do it up here. We'd say mole man and make him a mole. Mole, mole, mole. New mole man, and we have to at least pass it an age and a height. So let's just make his age like what, 16. He's a young mole man. His weight, he's pretty light. Let's make him maybe 110 pounds or whatever. Actually, we didn't need that. All right, and then of course we need our semicolon at the end. Then what we can do is we can come here, C, and do a V. And we could say a mole and mole. So now, as you can see, we didn't have to write very much code at all. I mean, we could write code for swimming. Maybe he doesn't swim as fast as a fish man, so like he would be swim distance divided by 2, half the distance or something. Maybe he doesn't jump as high as a bird man because birdmen are relatively light, I would guess. They got hollow bones and stuff. So we could have our individual guys having their code for when they do something specific. Yeah, that's it. But let's go ahead and run this, and you'll see our mole man. And maybe what we'll say, let's just make this so, let's just make it a little more obvious. Well, who's saying what? We'll say BIRDMAN-SAYS, Birdman says, and then we'll just do that, and then we'll come down here, we'll copy that, just hit enter here, hit V, and we're gonna say mole man, and we're gonna do a escape character for a new line, do a C, maybe do an extra character term there. And this is mer. So here we have all our people, merman, birdman, and stuff. So now if we run this, it'll be a little more clear who's talking. So mole man says, birdman says, flying, I cannot dive. Mole Man said, I did that backwards. This is not Mole Man, this is Merman. Merman. This is what, when we were talking about logic errors, this is a logic error. Mole Man. Okay. So the program actually runs fine. So here we have the Birdman. He's flying, but he cannot dive. Merman says, I'm diving, but I cannot fly. And then poor Mole Man says, I cannot dive and I cannot fly. So hopefully that makes some sense to you. Like I said, if it doesn't, it will if you get deep into Java and you actually start working on big projects. I think probably the most useful thing that we actually got out of it is what they introduced into Java 8, I believe, is this default, where you can have a default, so I don't have to actually have that same method in every one of these saying the exact same thing. I can actually just have it automatically do that. That's probably the only place I can see that it's very useful, because I mean, void jump, yeah, I have void jump in here. I have a jump in here. I could have put jump in all of these if I wanted them jump, right? So there you have it. Hopefully it made a little bit of sense to you. If you did enjoy this video, please be sure to leave a thumbs up down below. Aside from that, comment, like, and subscribe. Follow me on Twitter. Check out my Discord and my other channels. And that's it. Until next time, I'll be seeing you later. Bye.